Question 35. Which amine has only 3 peaks in its proton NMR spectrum? So proton means hydrogen. 3 peaks, 3 different peaks means 3 different hydrogen environments. The easiest way to do this, you're not going to do this without drawing them out, so let's draw all 3 out. So methylamine has got a CH3 with an amine, an N, and therefore it's got to have 2 H's on it, because there's a methyl and then an N, and then the N has got to have 3 bonds, 1 bond to the carbon and then 2 H's. Trimethylamine, so 3 methyl groups, 3 methyls around an N, so that's a tertiary amine with 3 methyl groups off the N. Diethyl, and ethyl is a CH3CH2, it's got 2 of them, diethyl amine, so the N is bonded to a carbon and another carbon to the 2 ethyl groups, and it's got 1 H. And the propylamine is got 3 carbons in a row, bonded to the N, and the N then has got a propyl group and then 2 H's. The H's contribute as well to the proton NMR, so let's count up the number of different hydrogen environments. To make it easier to see, I've colour-coded them. There's 3 H's there bonded to the same carbon, I've called them red. 2 H's bonded to the N, I've called them blue. 2 different colours, 2 different carbon environments, the answer is not A. Each of those methyl groups, all the 3 methyl groups are bonded to the same atom to the N, so they're all equivalent. So all of those hydrogens, 3 lots of 3, all those 9 hydrogens are all equivalent. So that would produce 1 peak, so 2 peaks and 1 peak. Answer number C. Let's have a look here. So we've got 2 ethyl groups. The 2 ethyl groups are equivalent because they're both bonded to the same N, so they're both identical in that respect. The H's are different from the CH2s, so let's call those red, let's call those blues, and we've got an NH here because it's bonded to 2 ethyl groups. It needs a third bond in H. There's 3 colours there, so that'll produce 3 peaks, 3 different hydrogen environments. Let's just check D, just to be sure. CH3, CH2, CH2, those 2 are different colours, a blue and a sort of brown colour there. I've labelled it because that CH2 is joined to an N, whereas this CH2 is joined to a CH3 and a CH2. So those 2 are different environments. And then you've got the N bonded to one of the carbons of the chain at the end of the chain, NH2. So I've got 4 different peaks there. So I've got 2 peaks on A, 1 peak on B, 3 on C, 4 on D. The answer is C.